Okay, so let's begin talking about Unit 7.8, which are our differential equations. To kind of tie it together, you might find patterns or similarity between implicit differentiation when we talked about derivatives. Okay, so our first question tells us to find a particular solution that satisfies the initial condition that dy dx is equal to x over y. So what we're just going to do is we're going to break this down step by step. So where do we start? Well, of course, we're going to start with our original formula. And what do we do next? What we're going to do is we're going to separate the variables. What does that mean? It means that I want x and dx on one side, y and dy on the other side. In this particular solution, we're going to cross multiply. It's pretty easy. We know how to do that. And we get y dy is equal to x dx. From there, here's step 2. The most important part of this is we have to determine the antiderivative, which basically just means take the integral. We know how to integrate. The integral of y is y squared over 2, x squared over 2. So we do that. Technically, because I know you guys are going to ask, where did this plus c go? Yes, there is technically a plus c, but all we do is really combine them, so we only have plus c on one side. From there, what we're going to do is we're going to write our solution in terms of y. Okay, we know how to do that. That's pretty easy. But before we can write our solution in terms of y, you can either write your solution in terms of y and solve for c, or you can solve for c and write your solution in terms of y. It just depends on the question. In this one, we're going to go ahead and solve for c. It's pretty easy. So we plug in, because we know these conditions. Y of 0 is going to equal 4. So this is my x value. This is my y value. So I plug it in. My y now becomes 4. My x now becomes 0. And from there, I can solve for c. And we know that c is now going to equal 8. So I plug it in and solve for y by itself. So when we do that, we get y is equal to plus or minus the square root of x squared plus 16. Okay? But we have a plus or minus, so we actually want to determine which one it is. Is it going to be positive, is it going to be negative, or is it going to be both? Well, we ended up picking just the positive values. Why did we choose those positive values? We can look for our answer in the question. Y of 0 is equal to 4, so let's plug that in. Put 0 right here. So instead of x squared, it says 0. So it now becomes the square root of 16. The square root of 16 is equal to positive 4, and it's equal to negative 4. But what value did we get? Only positive 4? Then it means it must be our positive solution. Okay, we have another example. So let's go ahead and do that. Step 1, let's separate our variables. So we have dy over dx is equal to xy. And I'm going to bring my dx over. I'm also going to get rid of my y over here. And this becomes 1 over y dy is equal to, x dx, right? Step 2, I'm going to integrate it. We know this one, we should have that memorized. That's the ln of the absolute value of y is equal to x squared over 2 plus c. So again, you have two options from here. You can either solve for c and then get y by itself, or you can get y by itself and solve for c. Well, what's happening with my y? Before it was just squared, that was easy, but this is the ln of y, so maybe it'll be easier for us to solve for our y first before solving for our c. So what I'm going to do, the opposite of my ln is, my inverse of my ln is e, so I'm going to take the natural e, or natural base e, okay? My e and ln are going to cancel out, and I'm going to get that y is equal to e2 x squared over 2 plus c. Okay, so now I've got y by itself. I'm going to go ahead and plug in my conditions. We know that y of 2 is equal to e squared, so here's my y value. So this becomes e squared is equal to, I keep my e here, this x is right here, so 2 squared over 2 plus c. So this now becomes e squared is equal to, this becomes e 4 over 2 is just 2 plus c. Well, this says e squared is equal to e squared plus something, so there was only one value this plus c can be, and you guessed it, it is 0. So my c is going to equal 0. So if I want to rewrite that particular solution that satisfies this condition, y2 is equal to e2, then my answer has to be the one I didn't pass by, has to be y is equal to e to the power x squared over 2. And we would normally have put whatever c was right here, plus c, we would have substituted it in, but it's plus 0, so we can just leave it off. Okay, here's another example, same thing. But this one says solve y prime. What is y prime? Well, y prime is simply what we know as dy dx, isn't it? So So dy dx is now going to be equal to 3 sine x, and we do the exact same thing. We separate our variables. In this case, we got lucky. It's so easy. I just have my dx's, and then I integrate. And that becomes, the integral of just dy just becomes y is equal to 3 negative cosine of x plus c. My y is already separate, so now I'm just going to plug in my conditions, and I'm going to plug those in. So there's my x value. So this is equal to negative 3 cosine of pi over 3 plus c. This is my y value is 9. If I plug all those values in, this cosine of pi over 3 is 1/2, negative 3 over 2. I'm going to add that over, so I'm going to get c equals 21 over 2. And then I plug that into my equation, so it becomes y equals negative 3 cosine x plus 21 over 2. And here is that solution right there. Oh, I thought somebody tried to come in. Okay, here's our next question. This says solve the differential equation dy dx so that it satisfies the initial condition. This is saying the exact same thing. I think you guys can do this, but the initial help to set you up would be that separating my variables. I would remind you about factoring out. So this is actually y minus 2. So when I separate my variables, I get 1 over y minus 2 dy is equal to 2x dx. From there, you should be able to integrate and plug in our conditions y1 plus 3. Okay, as an answer. Again, same thing. I know it's worded differently, but the same question. So if you're finding a function who's passing through some point 0 to 6, so there's our x and our y, that has a first derivative. So same thing. So I'm taking my first derivative, integrating it back to our function. That's all we've been doing. So again, you guys should be able to do this one. Here's an answer for you. Question 6 just asks, once again, if I know that it contains some points. So same thing, but this one we're just going to break it down really quick. So the first thing you're going to do is separate our variables. There it is. Then we're going to integrate it. To integrate this, you have to use u substitution. We're going to substitute u squared, or x squared is u. But when we come back, it's just going to equal this. We plug in our initial, our condition, sorry, our 0, 1. We get that c is equal to 1, and we can solve from there. We can't see it at the bottom, but it says y is equal to the square root of 2 minus, or cosine x squared, sorry, yeah, that right there. Okay? Now we're going to talk about some matching. I told you guys this with slope fields, but we're going to talk about it again. When we are looking at dy dx, what does dy dx mean? It means the derivative. So we're not looking at a function. We're not even looking at the integral. Sorry about that. So we're not even looking at the integral, we're looking at the derivative. So if I am looking at the derivative, I will remind you of that relationship, f, and f. So what is this? This is my integral, this is my function, this is my derivative. And so what does that tell us? Well, it tells us that this is a pattern, right? It goes in this direction. So how do I go backwards? If I have a derivative, how do I go backwards? We know this from the fundamental theorem of calculus. If I take the integral of a derivative, it should give us our function, right? So that's what we're going to do here. What is the integral of x? Essentially, it's x squared. Yeah, it's x squared over 2, but essentially it's x squared.
Good afternoon, department chairs. Please pardon this interruption. Department chairs, please be sure to check your email before you leave today. Again, this announcement is for all department chairpersons. Please check your email before you leave today.
Sorry about that. So the integral of x is x squared. So what you're going to look for is a slope field that resembles x squared. Well, would you look at that? I see a parabola as I look at these slope fields, don't I? Okay. What about over here, question 36? Well, that would just be y squared. So I have to look for the square root of, all right? And then here we have a linear line. Here we don't have a linear line. Got something funky else happening. So again, what happens when y is by itself? And finally, we have some fractions, y over x and x over y. And so we're just looking for patterns, and that's how we develop these. So here's my semicircle pattern, which would have been the integral of x over negative x over y, and here is my other pattern. So really, you're just looking for patterns within your slope field. Okay, there were the answers if you were looking for them, but again, we're not seeking answers in these things, we are seeking understanding. Okay? Determine which graph shows the solution of the initial value problem without actually solving the problem. So we don't want you to do all the steps we just did. We want you to look for patterns. What do you know? How can we eliminate 2 of these questions and get the answer without even putting pencil to paper? Okay, well, what do we know? We know that dy dx is our slope, and we know that we are looking at this, but to look at our initial conditions, we have to actually look at the integral, which would give it our function. So the answer is going to be B, because my slope has to always be positive, because look at x. X is squared, so no matter what that value is, it's going to be positive. So A and C can automatically be ruled out because they have negative slopes. Here's question 50. I hope you pause and think about this before moving on. But again, don't solve it. What patterns do we see? Well, on this one, we can't just say, okay, well, slope negative. No, that's not going to be just the answer this time. Our answer is actually still B, but it's because the solution should have a positive slope when x is negative, and it should have a negative slope when x is positive. So that was the pattern, hopefully, you saw. Believe this concludes, this concludes 7.8. Sorry about the small interruptions here and there, but I'll see you next time for 7.9.